What do we add to this to get negative 3? What do we add to negative 10 to get negative 3? So yeah, I think you're right. Let's plug it in and see. So the way that we know for sure is we take the second term, which is negative 3, and we subtract the first term, which is actually negative 10. Let's see. Positive 7. Right? It's positive 7. So I think, let's double check this. I think that if I add 7 to this, that's how I get there. So let's try it and double check. So I'm going to start with negative 10, and then I'm going to add 7 to it. And I get negative 3. Now I'm going to add 7 to that, and I should get 4. I get 4. If I add 7 to that, I should get 11. If I add 7 to that, what do I get? I get 18. If I add 7 to that, I get 25. And then if I add 7 to that, I get 32. So my next two terms are 25 and 32. My common difference is actually plus 7 or just positive 7. In other words, to get from this term to this term, I'm going to add 7. To get from this term to this term, I'm going to add 7. This is a sub 1, a sub 2, a sub 3, a sub 4. And we call that subset notation. Okay? All right, we're almost done. Now let's talk about the explicit notation. All right. We say that a sub n is equal to, what would be the term before negative 10? In other words, if I were to go in this direction, I would actually subtract 7. So what if I subtract 7 from negative 10, what would I get? Yeah, negative 17, right? Then I'm going to add 7 times n, whatever n is. Let's pick out a term and see if we're right. I'm going to pick out like the 6th term. Okay? So, in other words, my term would be let n equal 6. Does that make sense to you guys? So that means wherever there's an n, what do I plug in? You need to be writing this down. So wherever there's an n, I'm going to write in 6. So I say a sub 6 is equal to negative 17 plus 7 times 6. Now, if I do that right, remember this is a sub 5, this is a sub 6, and this is a sub 7. So I should get 25 for my answer. So if I say negative 17 plus 7 times 6, and I close the parentheses, when I hit enter I should have 25. And I do. So this explicit formula is like an equation that if I want to know what the term is, in other words, this is the 6th term. If I want to know which term it is, I just plug it into the formula. So you guys pick out a number, not too big, but let's pick out a term, like the 23rd term. So if we'll do the 23rd term. So if I want to know what the 23rd term is, then what do I plug in for n? N equals 23, right? So then, for my 23rd term, I'm going to zoom out a little bit. I'm going to say a to the 23rd is equal to negative 17 plus 7 times 23. So the explicit is like an equation that gives us the number of the 23rd term. And I just plug in 23. All right? So let's do that. If I say negative 17 plus, whoops, I got to pull this out a little bit, plus 7 times 23, it's 144. That's nice to know because the 23rd term in this sequence would be 144. Now the question was asked earlier, Mr. Adams, what's the difference between that and the recursive term? Well, the recursive term is a little different. It's like saying the next term is equal to the previous, and I wrote it backwards up here. I said the previous term is equal to the next. I'm sorry about that. But it's equal to the previous term plus 7. So if I say I want to, and then we define this as, we would say a sub n is equal to a sub n minus 1 plus 7. So, and we had to define that a sub 1 was equal to the first term, which was way over here, negative 10. Right? So then a sub 2 would be equal to a sub 1, which is the previous term, which will be negative 10 plus 7, which is equal to negative 3. The third term, a sub 3, would be equal to a sub 2, which was negative 3, plus 7, which is equal to positive 4. A sub 4 would be equal to the third term, which is 4, plus 7, which is equal to 11. The fifth term would be equal to the previous term, which is 11, plus 7, which is 18. So this recursive notation is great if you already have the previous terms, but this would be really hard to figure out the 23rd term, right? You'd have to go through this process 22 times, or, well, not all 22, but over 20 times to get, or close to 20 times to get to the 23rd term. So the explicit formula has a benefit in the fact that if you know what number or term you're going to use, you can just plug it in and figure out, you know, the value for that term. The recursive will get you the same answer, you just got to repeat a lot, right? And we could see that with the recursive. If I say negative 10, let's put it down here so you can see it. If I say negative 10 plus 7, I get my negative 3, and then if I add 7, I get my 4, 11, 18, 25. But now to get to the 23rd term, I have to keep doing this and keep doing this. Now we said that the 23rd term would be 144, but you know, it takes a lot more steps to get to my 144. Does that make sense? Okay.